got parametric equations here. So x and y, they are kind of dependent upon each other, but we get the relationship through a third parameter, t. And we're asked, oh, you can do lots of things with this. And in fact, I think any Cartesian curve can be written in parametric form, but some parametric equations cannot be written in Cartesian form. So it's like a more general form. First up, we're asked to find dy by dx. And that we can use the chain rule for. So it's going to be dy by dt, dt by dx. Because we don't have y in terms of x directly, but we can do it through this relationship. Now, dt by dx is actually 1 over dx by dt, so we can turn it around to be dy by dt over dx by dt. All right, well, x is t plus 2t to the minus 1, which means dx by dt is going to be 1 minus 2t to the minus 2. And if I write it back as a fraction, it's going to be 2 over t squared. And then similar for y, we're going to get y is then t minus 2t to the minus 1. So dy by dt is 1 plus 2t to the minus 2, or 1 plus 2 over t squared. And we're mostly there now, so it's going to be 1 plus 2 over t squared all over 1 minus 2 over t squared. The only thing is we're asked to write it in its simplest form, and this is not in its simplest form because I've got fractions within fractions. So I'm going to times through by t squared, top and bottom, which gives me t squared plus 2 all over t squared minus 2. And that is our dy by dx. Right, in part 2, we're asked to explain why there's no stationary points. So let's try and find them, I guess, and see what goes wrong. So for stationary points, dy by dx is going to equal 0, which means that t squared plus 2 over t squared minus 2 is going to equal 0. And the thing is, you can't possibly divide by anything to cause it to equal 0. It must be actually that the top is equal to 0. T squared plus 2 must equal 0. If you don't like my explanation there, think about multiplying both sides by t squared minus 2. It will disappear from the left, and then we'll do 0 times t squared minus 2, and we'll get 0 again. So that is definitely the case. And t squared plus 2 equals 0 has no solutions. Because it's an explain question, maybe I should just say a little bit more. So since t squared plus 2 is greater or equal to 2, it can't possibly equal 0 because this thing is always positive, and then we're adding 2 to it. I mean, oh, sorry, greater or equal to 0, I should say, because t could be 0. Or you could say that t squared equals minus 2 has no real solutions. So therefore, there's no stationary points. In part 3, we're asked to consider x plus y or otherwise to find a Cartesian equation for the curve. Essentially, that means eliminating t and getting y in terms of x. And we have to avoid fractions or brackets. So it makes sense to heed the advice given, and let's find out what x plus y is. It's going to be t plus 2 over t plus t minus 2 over t. So these are going to cancel. X plus y is equal to 2t. Now we've not actually eliminated t from it, but this will give us the ability to, because I can now make t the subject. T is going to equal a half x plus y. And I'm now going to substitute that back in to the equation for y. So y is going to equal a half x plus y minus 2 over half x plus y. Right, now I can, if I'm dividing by a half, it's actually the same as times in by 2, so I can change this to a 4. And then next up, I'm going to multiply through by 2. I'll do it in stages. So 2y is equal to x plus y minus 8 over x plus y. I'm going to multiply through by x plus y, but I just noticed before I do that, I can actually minus y from both sides and make it y equals x minus 8. It's just going to make life a little bit easier, I think. Okay, I'll go with it from there. So y x plus y is equal to x plus y minus 8. I multiply through by x plus y. So xy plus y squared is equal to x squared plus xy minus 8. And these are going to cancel. So I'm basically there. I don't know how it's best to write it. Y squared, I could just leave it as y squared equals x squared minus 8. That seems okay. Or I could even rewrite it as x squared minus y squared equals 8. I'll go with that one, but the other should be okay as well. So there we go. We've managed to get the Cartesian equation by eliminating t, and we are done.